Section 7.5 is on properties of logarithms. First is the product property of logarithms, and that says that log base x of a times b is equal to log base x of a plus log base x of b. And that is a, b, and x have to be greater than 0, and x cannot be equal to 1. So in other words, if I have two things multiplied here, I can break them apart, factor them, and then use addition to evaluate the log. Here's an example. Log base 2 of 30 is equal to log base 2 of 5 plus log base 2 of 6, because 5 times 6 is 30. Similar thing applies for quotients. So the quotient property of logarithms says log base x of a over b, or a divided by b, equals log base x of a minus log base x of b. Here's an example. Log base 2 of 3 over 5 is equal to log base 2 of 3 minus log base 2 of 5. So here I have 5 divided by 3, and then over here I can write it as 5 3 divided by 5, and here I can write it as 3 minus 5. The power property of logarithms says log base b of m raised to the power of p is equal to p times log base b of m. In other words, the exponent on what you're taking the log of can actually move to the front of the log and act as a coefficient. Here's an example. Log base 10 of 5 to the second power is equal to 2 times log base 10 of 5. Here's a few other miscellaneous properties of logs. Log base b of 1 is equal to 0, because if you were to take that and write it in exponential form, b to the 0 equals 1. Anything to the 0 equals 1. Log base b of b is equal to 1, because, again, writing it in exponential form, b to the first power equals b. Log base b of b to the x equals x, because, writing it in exponential form, b to the x equals b to the x. And b raised to the power of log base b of x equals x, because if we were to take this and write it in logarithmic form, we would have log base b of x equals log base b of x. So let's take a look at a couple examples here. So use the fact that log base 4 of 3 is approximately equal to 0.7925, and log base 4 of 5 is approximately equal to 1.1610 to approximate the value of each expression. So here we have log base 4 of 15. Well, I can rewrite that as log base 4 of 3 plus log base 4 of 5, because using the product property backwards, or actually using the product property, since 3 times 5 is 15, I can break it up into addition. So log base 4 of 3 is approximately 0.7925, and log base 4 of 5 is approximately 1.1610. Actually, I should probably have a squiggly equals here. And that's approximately equal to 1.9535. Okay. Number 2, log base 4 of 3/4. Well, that's going to be equal to, using the quotient property, log base 4 of 3 minus log base 4 of 4. Okay, so I'm given log base 4 of 3 is approximately equal to 0.7925, and oh geez, I wasn't given log base 4 of 4. But going back to this property over here, log base b of b equals 1, this is just equal to 1. Log with the same base of what you're taking the base of is just equal to 1. So that's approximately equal to negative 0.2075. And my last example here, log base 4 of 125. And I was trying to think, let's see, well, so what could that be? I don't know anything, 3 times 5 doesn't equal 125. But I can rewrite this as log base 4 of 5 to the third power, because 125 is 5 cubed. So then, using the property that says I can take that exponent and put it out front, that's going to be 3 times log base 4 of 5, or approximately 3 times 1.1610, or approximately equal to 3.483. Okay, so there's an example of how you're going to use primarily the quotient and product properties. And now we have a couple equations to solve. Here we have log base 10 of x plus log base 10 of x plus 21 equals 2. So I'm going to use the product property in reverse. Since these bases are the same and I have addition here, I can write this as log base 10 of x times x plus 21, and that equals 2. So these two things being added here, I can combine them using multiplication. Now let's take this equation and write it in exponential form. I'm going to take my base, which is 10, raise it to the power of what it's equal to, which is 2, is equal to what I'm taking the log of, x times x plus 21. Now I have an equation I can solve. So that's 100 equals x squared plus 21x. This is a quadratic equation, so I want to make it equal 0, so I'll subtract 100 on each side. And factoring this, I'll get x plus 25 times x minus 4. So that means that x is equal to negative 25 and x is equal to 4. But looking back at my original equation here, I cannot take the log of a negative number. My x always has to be positive. So it's not negative 25, so x is equal to 4. And our last example here, log base 10 of 18 minus log base 10 of 3x equals log base 10 of 2. So let's go ahead and use the quotient property over here. And since I'm subtracting, I can say log base 10 of 18 over 3x equals log base 10 of 2. And since I'm taking the log of each side, I can kind of just, it's not really canceling it out, but I don't have to worry about that. So I can say it's 18 over 3x equals 2. And now I have a very straightforward equation to solve. Multiply both sides by 3x. 18 equals 6x, or x equals 3. And that's going to be okay because the only place I had an x was here, and so that makes it a positive value that I'm taking the log of. So in this section, we took a look at a bunch of different properties of logarithms, how to use the product and quotient properties, a few miscellaneous properties, and the power property.